Alrighty, next up we're going to focus a little bit more on this thing that we were talking about earlier called end behavior. We defined it earlier, but now let's figure out what we actually do with it. There's actually a couple definitions I want us to add up at the top of the screen here. The first definition you'll see in this table here. I was about to point on the screen, but on this table here we talk about this thing called an odd degree and an even degree, and we also have this LC. Let's start with the term degree, and so I'm just going to have you jot this at the top here. The definition of degree. It might be something that you're already familiar with, but just in case you're not, let me shift this a little bit. A degree is the highest exponent of a function. So it's your highest exponent of a function. Now, the LC, that is short for leading coefficient. The leading coefficient is, and I'm going to use some just generic terms here again, it's the number in front of the first term. And I'm going to actually add one more thing to this, and it's something we're going to focus on a little bit more later. I'm going to say in standard form. So in standard form. That's something you're probably already used to, whether you realize it or not. So talking about a couple different examples here. So we're going to say p of x, that's going to be our generic function. We're going to come up with one that has an odd degree and an even, or say a positive leading coefficient. So the example I'm going to give is p of x, since we're talking about p of x here. P of x equals, and I'm going to say 6x to the third. So it's got a positive leading coefficient. In that case, it's that 6. And then an odd degree, again, degree is your highest exponent. This one only has one exponent, so the exponent is 3. This graph is going to look a little something like this. This is not going to be exact, but it's going to be a good representation of what's going on. So it'll look something like that. That's not perfect, but it's good enough. It's got some sort of curve in it. It's the cubic graph that we kind of looked at before. Now, the end behavior, we're going to write it like this. We're going to say as x approaches negative infinity, that terminology I was using on the previous page, as x approaches negative infinity, so as we're going further and further to the left on the graph, I have to think about how to teach this with the camera, so it's to the left on the graph. We're going to say as x approaches negative infinity, we're going to say p of x, the function that we're talking about, the one that we graphed, is approaching, well, if we're kind of talking about this one is going, if we're going to the left, kind of think about it as like a roller coaster or something. If we're going further and further to the left on the roller coaster, what's also happening? Well, this one's also going down. So we're going to say p of x is approaching negative infinity. So we described what's happening to the graph as it goes to the left. Now we also have to include the description as it goes to the right. If you remember correctly from the previous page, we're going to say as x approaches, in this case, positive infinity, then we're going to say the function p of x, and again, thinking about it like maybe a roller coaster, if we're going to the right on there, it's going up, 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 forever and ever and ever. We're going to say it approaches positive infinity. That was not my best infinity symbol. Let's give it another go. So as x approaches negative infinity, p of x approaches negative infinity, and as x approaches positive infinity, so as it goes to the right, no, you're right, it's that way, it's going up to positive infinity. Now let's try one with an even degree. So I'm going to say this one's going to be a different one. It's going to be p of x equals, I'm going to use the same leading coefficient, still 6, just a positive number. And instead of 6x to the third, let's do an even degree, so an even number exponent. We're going to say 6x to the third. Sorry, goodness, I just said that. 6x to the third, we're going to change it to 6x squared. So that's going to be a quadratic graph, and it's going to have that U shape, that parabola shape. That looks something like that. Again, this is not an exact graph, and that's not the important thing. We don't really need it to be exact right now. We just need it to be representative of what's kind of going on in the graph. Now, the end behavior for an even degree is still going to start the same way. We're going to say as x approaches negative infinity. You'll notice this is something that's going to be repeated over and over and over. So this gets repeated here. Doesn't matter the leading coefficient, doesn't matter the degree, you're always going to talk about what happens to the graph as it goes to the left. So as x approaches negative infinity, in this case, p of x this now p of x, which is 6x squared, is approaching, again, thinking about it, if we're going further and further and further to the left, we're going up, 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 up. So we're going to say p of x approaches positive infinity. It's pointing up. We're also going to say as x approaches positive infinity, so what's happening as we go further and further and further to the right on the graph, we're going to say p of x, probably should put some commas here, p of x approaches positive infinity. One way you can think about this description, so again, the as x approaches negative infinity and as x approaches positive infinity stays the same regardless of which type of function you're talking about. But on this one, this graph for 6x squared is pointing up and to the right and up and to the left. Both sides are going up and up and up forever and ever and ever. They're both going to positive infinity. For a negative leading coefficient, I'm going to use the similar numbers, but we're going to say, in this case, talking about whatever the function is, p of x, p standing for polynomial, equals, instead of 6x, we're going to say negative 6x, and I'm going to still use the odd of to the third. You could use to the fifth, to the seventh. It doesn't really matter what you're using. Like the sixes that I'm using here, I could change those up, as long as we're talking about the positive numbers and negative numbers. So in this case, we have a negative 6. It could be a negative million. It could be negative 4. It could be whatever negative number. And again, odd degree, it can be any odd number. I'm just choosing the third to make it consistent, to show you how it's related, but also how it's different. So let's draw a quick graph there. This graph is going to look very similar to the shape that we drew above it. It might not be perfect because we're humans, but it's going to go in an opposite direction. Oops, sorry, that's a line. Well, it wouldn't be the worst thing if I drew a line, but maybe the graph looks something like this. Again, not perfect, but good enough. We're going to say as x approaches negative infinity, and again, folks, that's something you should write every time you're writing these end behavior statements. As x approaches negative infinity, we're going to talk about this specific one. We're going to say this p of x, this polynomial, approaches, well, on the left side of this one's pointing up. It's going up and up and up forever. So we're going to say p of x approaches positive infinity. The other part, as x approaches positive infinity, p of x approaches, well, on the right side of this graph, take a moment and think about what's going on the right side of this graph. This one's going down. So this one's going to negative infinity. Again, just highlighting the part that's always going to be the same. You're always going to say as x goes to negative infinity, sorry, to your left, and as x goes to positive infinity, to your right. Last one. So this one, following a similar pattern, we've got a negative leading coefficient, so we're going to stick with that negative leading coefficient of negative 6. And an even degree, we're going to go x to the second. Could be x to the second, x to the fourth, x to the sixth, as long as the exponent's an even number. So one last graph for this guy. This one's also going to be a parabola, but it's going to be a parabola facing in the opposite direction. Now I need to move my screen a second because I realized that my picture's over it. There we go. So we're going to say negative 6x squared. So it's facing the opposite direction. It's pointing down in this case. We're going to say as x approaches negative infinity, again, same as we've included for everyone so far. As x approaches negative infinity, p of x approaches this one on the left side of the graph. It's pointing down. So we're going to say it's going to negative infinity. Again, if you're riding a roller coaster, you're going to the left direction, you're going to be going down forever and ever and ever and ever. You'll never end. The other side, as x approaches positive infinity, p of x, this graph, is going, so as we're going to the right, got to remember to teach backwards now, as you're going to the right on your graph, it's also going down to negative infinity. We're going down, 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 forever and ever and ever. We're going to practice these in just a couple minutes.